Swayam Prabha. Digital India. Educated India.
Welcome to the next session in this Organic Chemistry 2 paper, the module 3. We are now studying about worked out problems, that is alkyl halide reactions. Now in the third lecture we will be studying about nucleophilic substitution internal mechanism and application. I am Dr. Balaji, currently working as Associate Professor in the School of Biotechnology at Jawaharlal Nehru University. This project was sponsored by DTH Swayam Prabha, MHRD, New Delhi. The topics that will be covered in this particular session include examples of SNi mechanism, that is internal nucleophilic substitution mechanism, in the presence and in the absence of base. Let us study about SNi mechanism. This is nucleophilic substitution internal. We have already seen this particular reaction specifically for the preparation of alkyl halides from alcohols, that is the Darson's method. So here an alcohol reacts with thionyl chloride in ether to give RCl plus SO2 plus HCl. So these two are basically gases which escape from the reaction medium, and we end up with the alkyl halide as a product. Let us look at the mechanism for this particular reaction. Let us take this alcohol. The oxygen has lone pair of electron. So in the first step, the oxygen bonds with the sulfur with the concomitant removal of the halide. So this gives an intermediate. Due to this, the oxygen gets a positive charge. So this Cl minus is liberated. This Cl minus then abstracts the proton. So this bond shifts to oxygen. This leads to the formation of the chlorosulfite. The chlorosulfite is a good leaving group, and what we form here is a intimate ion pair where the chlorosulfide and the carbocation both exist together. This chlorosulfide chlorine cannot internally attack the carbon. Formation of the carbocation, because here the carbocation is formed from this carbon, because this carbon oxygen bond cleaves to produce a carbocation and oxygen, negative charge on oxygen, because this oxygen takes away both the electrons because it is more electronegative than the carbon. In this heterolytic cleavage, oxygen retains its electrons from this bond. So we end up with a carbocation and the oxide minus ion. So here the internal transfer of bonds leads to the formation of our final product, which is the alkyl halide, and sulfur dioxide is lost here. So finally the alkyl halide is formed through internal substitution mechanism. And here what we see is, in the starting material, from whichever direction the oxygen, that alcohol group is lost. So this alcohol group is lost and the halogen is also coming from the same side. The loss of alcohol, that hydroxy group, and the attack of the chlorine both happens from the same side. So in this particular case, the product what we get, retention of configuration. So this is one method in which we can explain how the retention of configuration happens in the through SNi mechanism. Even though we have a carbocation intermediate formed in this particular reaction, this carbocation leads to retention because it is an internal attack. The chlorine attacks internally, so that's why we get a retention of configuration. In the presence of the pyridine base also, the initial steps are very similar, and here we will be just looking at the oxygen attacking the sulfur with concomitant removal of chlorine, and Cl minus is lost in this particular step, which abstracts this proton to give the chlorosulfide. So up to here it is very similar. So in the next step, the pyridine is the one which is actually happening in this particular case. The pyridine attacks the sulfur and the oxygen, the double bond electrons are shifted towards the oxygen. So we end up with a ionic intermediate where so the oxygen gets the negative charge and the nitrogen is having a positive charge. So this ionic intermediate is formed. In the next step, during charge reversal, the negative charge comes between the sulfur oxygen bond and the chloride is lost as a Cl minus ion. This leads to a stable product with the pyridine attached to the sulfur. Since in this step there is nothing happening to the nitrogen will still retain the positive charge. So in this particular step, the chloride ion can come and attack the carbon from the rear side, and the bond is cleaved between CO bond is cleaved and the S double bond O form bond leads to the formation of sulfur dioxide, and SN bond cleaves to regenerate the starting the base, which is the pyridine. So thus this reaction completes. So far we had studied about the internal nucleophilic substitution reaction. We studied its mechanism also in the presence and in the absence of the base. So in the presence of a base we are getting inversion, and in the absence of the base we get retention in configuration. With this we conclude this particular module. Thank you.